Okay, linear systems. So for linear systems, we're going to take a general overview of the three different systems you can have. So we'll do a little Cartesian plane here, then we'll go on a graphing software and show it. But you have systems. We'll do them in black to start. That's not what I wanted. I want a line. Yes, there you go. Systems that graphically look like this. Okay? And when you have graphical systems that look like this is also a common symbol in math. They're known as parallel. And what this means is that these systems have 0 points of intersection. Okay, so they do not cross. They're parallel. They do not cross each other. Our other systems. Oh shoot. Is a system like this, and it's a system that has 1 point of intersection. It'll look like this, 1 point. And then finally, the last system that you could have, okay, we'll do them in blue here, is I'm going to draw directly on top of each other, okay? Hopefully it makes it look a little thicker. Oops, that didn't quite work. It goes like this. There we go. These are systems that have infinite points of intersection, okay? And the question becomes, how do you tell the difference? So graphically, it's really easy to take a look and be like, yeah, that's it. But this all has to do with y equals mx plus b, which is the point y-intercept slope of a line. And what you're going to do is you need to pay special attention to this idea of what m is, okay? M is slope. This is what's really important here, yeah. And then from slope, we make a couple other checks and points, okay? So the very first one, the easiest one to deal with is probably 1 point of intersection. Any y, poor little girl, where the slope, m, is different. So where m does not equal, we'll call it m1 and m2. Okay, so we'll write two different equations here.
So they have to be the same?
No, it's the opposite idea. They have to be different. So you have y equals, this we'll call this one m2 plus b, and the other one is m1. Okay. Anytime they're not equal, you have 1 point of intersection. 1 point. And graphically, I'll show you what that looks like. So we have y equals m subscript 1 plus b. So it asked me for some sliders, so it gave me this. So there we go. We got oh, I forgot to put an x. I'm like, what's going on there? There we go. We have 1, and then I have another one. Y equals m underscore 2 x plus b. Okay. If you notice here, oh, I don't want to give it b. I'll give it a number 4. Okay. You'll notice that no matter what we do with our slopes here, okay,
They always intersect.
you're always going to intersect somewhere. It's moving around. It's when we get to this scenario. I don't know if I've done that properly. Oh, yeah, I have. Good. This scenario here, what do you notice about the two slopes? They're the same. So this brings us to our second point. 0 points of intersection. Okay? If m1 equals m2, we then have to do a second check. I'm going to say and b, we'll give this a 1 and a b2. b1 does not equal b2. Okay? So if the slopes are the same but the y-intercepts are different, we have 0 points of intersection. So notice here on our graph, oh, I forgot to show you what I was just writing. I was writing it down here. If m1 equals m2 and b1 does not equal b2, so those are the y-intercepts, we have 0 points of intersection. So what does that mean for us? Well, if we take a look at our b here, if the points of if the b or the y-intercept is different, they're just never going to cross each other. They will not until I do this. And there's your infinite. Exactly.
Same slope, different.
Same slope. Exactly. And then the final example, what color did I do them? I did them in blue, I think. If m1 equals m2 and b1 equals b2. In other words, well, slopes and y-intercepts are the same, then you have infinite points. Now you might say, well, that's really easy to look at. It's really easy to tell. But what they'll do in their questions for you algebraically, okay, is they'll do things like this. They'll write like 2y equals 3x plus 4, and they'll write something like 12y equals 24 plus 18x. And they'll say how many points of intersection. And this is tricky. You'll always want to get it into your single y equals mx plus b. Okay, you need to get it into that form. Oh, forgot to write my plus button. Or sorry, my plus operator here. You'll need to get it into this form in order to use this little chart, okay? Once in this form, we can compare everything we have. Let's say they call this equation 1 and equation 2. Okay, once you get it into that form, then you can reference your chart. Are the slopes different? Must be 1 point. Are the slopes the same? Okay, what about the y-intercepts? Slopes the same, y-intercept different? No points of intersection. Or is it slopes the same and the y-intercepts are the same? Well, then we have infinite points, okay? And to quickly show you that, I'm going to do that down here. This one, I wanted to get it all equal to y, so I'm going to divide everything by 2, okay? This becomes y equals 3 over 2 plus 2. And then this one here, I'm going to divide everything by 12. Y equals 24 over 12 plus 18x over 12. I got to simplify that a little. This is the same as writing y equals 2 plus, if I divide both of those by 6, yeah, that'll give me 3 over 2x, and then lo and behold, doesn't matter the order they're written in, those are actually the same equation, what we've written there, which means slopes are the same, y-intercepts are the same,
So it's
infinite number of solutions.
Okay.
So as long as you get into that form and you can just reference this little piece here, you can answer every one of those relatively quickly.
Okay.
Okay?